Okay, folks, on my last video, we went to the back side of the 5s, which was Mickey Mouse, and now we're going to work on the back side. So we already went through this slide. Now we're going to work these problems out together. Again, I hope that you take some time and try these problems yourself before just watching me go through it. The first thing I'm going to do is I'm going to assign oxidation numbers to all of the items. So this is a 3 positive. We learned this on the front side. This is a neutral element, so that's 0. This is a neutral element, so that's 0. And this has a charge of 3 positive, and so its oxidation number would be 3 positive. We're going to put oxidation brackets up on top. We're going to put reduction brackets on the bottom. I always like to start with the reduction brackets. So which element is reduced in number? Well, here we're going from 0 to 3 positive. That's an increase in number. Well, that's not our reduction. Let's try a different one. So here we're going from 3 positive to 0. So this is our reduction reaction. And when we go from Fe3 positive to Fe that has 0 for an oxidation number, how many electrons did it gain? We went from 3 positive to 0. So it must have gained 3 negative charges. So it gained 3 electrons. So that would be one bracket. I'm going to break my oxidation numbers up there again. 3 positive, 0, 0, 3 positive. So that's one set of information that we need. This aluminum is going over here, and we are going from 0 to 3 positive. So we got 0 to 3 positive. To become more positive, you must lose electrons. When you lose electrons, that is oxidation. So oxidation is the loss of electrons. So this is my oxidation reaction, and it must have lost 3 electrons. So that is the initial work that you have to set up. So it's asking what element is oxidized. Remember, for these parts right here, everything is on the reactant side. Nothing is found on the product side. So what is oxidized? Well, this aluminum is oxidized. What is reduced? Well, this Fe3 positive is reduced. Okay. Now, it gets a bit more confusing. So this is being reduced. This caused it. So aluminum losing electrons caused the iron to gain electrons. So, right again, this is being reduced. This caused it. So the aluminum is the reducing agent. Let's try this again. So we have aluminum being oxidized. Aluminum lost electrons. What did it lose electrons to? It lost electrons to Fe3 positive. So aluminum's oxidized. What caused it? The Fe3 positive caused it. So the Fe3 positive is the oxidizing agent. Now you're going to see a pattern show up really quick in this data table, and please try to avoid just filling in information and not working through the problem. It's very easy to find the pattern, fill in the whole table, and you're done with it, but you really didn't learn much from it. So let's try this next one. Try this one on your own, and then come back and watch me do it. So pause it, try this problem, and then come back, and we'll work it through together. So write the oxidation numbers: 3 positive, 0, 0, 3 positive. Those are skills from the front page. Which element or ion is reduced in oxidation number? Well, the gold, 3 positive ions, are turning into solid gold. That is a reduction in oxidation number. And a reduction is a gain of electrons. So this Au3 positive gained 3 electrons to become Au solid. So what was reduced? That was Au3 positive. Fe turned into Fe3 positive. Fe has an oxidation number of 0, and Fe3 positive has an oxidation number of 3 positive. So to go from 0 to 3 positive, you must have lost some electrons. Lost how many electrons? 3 electrons. And oxidation is a loss of electrons. So what's oxidized? Fe. Now, again, this is the part that becomes a little bit more cumbersome. So Fe is oxidized. This caused it. So Au3 positive is the oxidizing agent. So let me go through that again. Au3 positive wants to gain electrons. It's gaining those electrons from this iron. So that Au3 positive caused this to lose electrons. So therefore, Au3 positive is the oxidizing agent. Let's go through this the other way. This is being reduced. It's reduced because it gains some electrons. Fe solid is losing electrons. It's losing those electrons and forcing Au3 positive to gain them. Au3 positive is reduced, so Fe is the reducing agent. Those are all the problems that we did with the students in class, so the rest of them are for you to do on your own. If you need to, rewind this and go back up to some of the earlier problems and see how they are done. Have a good evening.